All right, this is OXDF doing Advent of Code Day 20 trench map. After the last couple ones, I think this one looks simpler, but those are kind of famous last words. So basically, I'm going to get an input with two different parts. The first part is going to be a single line that's 512 characters long and either contains dots and pound signs. And that is our image enhancement algorithm. So that's our algorithm. And then down here, we'll have an image. This is a 5x5 grid. The puzzle input will be much longer. Basically, we're going to imply an enhancement means to loop over every pixel or every point in here. And you look at the 9 points. So for this point, you look at the 9 points, really, the 3x3 grid around centered on it. And you're going to build a binary string out of that. So this becomes, the bit 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's always going to be 9 bits. So this will be 0, 0, 1, 1, 0, 0, 0, 1, 0, which they have right here. And then when you convert that from binary to decimal, it becomes 34. And then you can go to the 34th space in your algorithm, and you get, in this case, a hash. So that's what this new one becomes. And this string up here is always going to be 512 because 9 bits can support 0 to 1 to 511. It is important to say that they give you this grid, but it extends infinitely off. So this is in all directions going dots after just those, so that'll impact how we store the data. Yeah, so they show that here. So they apply it once they get this. Now you can take the input, the output of the first enhancement, and you can enhance it again, and you get another one. So in this case, for part 1, they're asking us to enhance it twice, and then count the number of pixels that are lit. I feel pretty confident that for part 2, we're going to be, enhancing it 100 times or something like that. But we'll get to that when we get to that, I guess. So let's get to work. Let's pull up my terminal here. So I've already got a little stub here, basically just going to read the data in. So we can then do a split here. So we'll say algo and image equals data dots. Let's strip it just to be sure. And we'll split on new line, and that should give us those two things. And then for the image, we're going to store it in a set because we can just then store a list of the points that are lit. So we will do image g for grid equals set. Then we will do for line in image dot strip dot split on new line. I don't know if we need that strip, but I don't think it'll hurt. Pretty sure we don't, but anyway. For char in line dot just in line. And we're gonna need to know the numbers as well. So we're gonna do enumerate like that, and then we'll do enumerate line like that. So then we need to come up here and we can do, when you put enumerate around something and iterate over it, you're just going to get, it's going to return the line, it's going to return the object, the number, the index for the object, and the object itself. So we can do like that. And now we just need to do if char equals that. G dot add r comma c. We put our point, if a point is lit, we put it into the grid. So I think that's pretty good for getting the data going. I think it's going to be useful. We could get kind of overconfident and not worry about it, but I think it'd be useful to be able to print the grid. So we'll call print grid g, and we will do, let's see. So we're going to need to know the min and the max values. So we'll say rvals equals p sub 0 for p in g. And so then min r comma max r equals min rvals comma max rvals. And then we'll do cvals equals p sub 1 for P in G. And we can do min C, max C equals min C vals, max C vals. And then we can do for R in range, min R minus 2, max R plus 3. And I'm intentionally making this one bigger because, you know, a range includes the starting value here and not the ending value. For C in range, min C minus 2, max C plus 3. And then we will do if RC in G, print like that, end equals like that, else print dot end equals that, and then after each line we will just print. That looks nice. So now we can come down here, do Python 3, day 20, 20 example, put a minus I here. Oh, string object not callable. Don't know why I have those there. So if we have G, it's our stuff. If we print grid on G, max 2. What did I call max 2? What line am I on? Oh, that should be max R. Print grid on G gives us that. So now if we G2 equals in, oh, we haven't done enhance yet. So that's what we need to do next. It's enhance. Okay, feel good though. We read our grid in and that grid looks like our starting grid. Yeah, awesome. Okay, so now we need to do enhance. Def enhance G. And so we're going to do, let's make this big again. What are we gonna do for enhance? We're gonna loop over, we're gonna basically do the exact same thing we did here. Like that, yank, paste. And what are we gonna do now? We're going to, for each point, we're gonna have to loop over the neighbors. So for dr in -1, 0, 1, for dc in -1, 0, 1. And the order does matter here because it's important that we go first -1, -1, so that's up left, then -1, 0, so that's up center, etc. So now we're going to check each point. We probably need bin string equals like that. So now we will do if R plus dr C plus DC in G. If that point is in G, then bin string plus equals. Oh, we can do this. We can do this like this would be kind of cool. Bin string plus equals 1, else 0, like that. So that will add in a 1 if it's there, if it's in the set, and a 0 if it's not. And then once we're done with that whole thing, we can say if, what do we call it up here? Algo sub. If the appropriate algo is equal to that, then g2.add r comma c, like that. So all we need to do now is come in here and figure out what the algo is, and that's just going to be simply int bin string comma 2. So converting it from binary to an integer. And I think we look good there. Let's see how we look. So if we print G, we look like we want. If we say G2 equals enhance G, we need to define G2 equals set. So if we print G2, None type is not callable. What line is that on? What does G2 look like? G2 is nothing. Do we have to return at the end of enhance? It would help if we returned at the end of enhance. Return G2. Run again. So if we now do G2 equals enhance G, if we do G2, we got some points. If we do print grid on G2, we have that, which I think looks very similar to what we wanted to have in the example. 3 and a 5 there. 3 and a 5 and a 2 and a 2 and a... Yeah, okay, that looks good. So then if we do G3 equals enhance G2, if we print G3, it's starting to look like an apple. It looks good. Awesome. We should, let's come up here. 4t in range 2. I'm expecting to make that number bigger. We will do G1 equals, G equals enhance G. We don't need the steps anymore. And then we will print part 1 len t. 35. 35, feeling good. $58.26. And it's too high. Okay. Come up here and we print. Print grid, did I call it? I already forgot the name of the function. Grid. Hopefully this is not so big it overflows my screen. Okay, I'm noticing something right away, and that is that there's like a border forming around the edge, which is weird. Okay, this is a problem. I remember thinking in my head and not saying out loud that it's important that if there's nothing, if it's all zeros, so if it's 9 dots, that it's a dot here, but it's not. And that means that after one round, everything out in infinite space is actually going to flip back to being on, so it's going to be blinking. And let's see, where's the end of our algorithm? So if it's 8, if it's all on, it's going to go back to off. So that's going to really throw a wrench in how we handle this. Because we can't assume about all of space anymore. You know, this, we could potentially just grow this really big, but I don't think that makes any sense. I don't think that works. I mean, we could just do a really big thing and then somehow figure out where the fake space is versus the real space, but I don't, that seems tricky. I think what we need to do is track whether default is, we could track whether default is on or off. I think that's what we'll do. And so let's say, like, is it light out? So at first, this is going to be false. And basically what we can say is, if it's light out and we're outside of the maximum, and we're outside of every point more than one outside of the previous one, is going to be the default. So what if we come down here and we say, is it easier to track? Well, let's think about this. Okay, so this is the part that's going to become more complicated. Of course, the part I thought I was being slick on. So we'll do if r plus dr comma c plus dc in G. If that's, then we're definitely going to add the 1. We're good with that. The challenge is going to be we need to play to figure out like what to do if R, if it's outside the range, it's going to be if it's outside the max and the min. Yeah, okay. So then we can also do if R plus dr is greater than max R. Let's do this differently. If not, min R inclusive R plus dr plus inclusive max R. So if that's not the case, or if not, min C less than or equal to C plus DC less than or equal to max C. So if our point is out of our range, we haven't been keeping it, then and light bin string plus equals 1. And then if it's in the range and it's not in G, or if it's not light, so this will be elif, and then this will be else bin string plus equals 0. So let's see if that works. I'm just kind of not sure, not feeling super confident in that. Need position of light. Oh, okay. So whether it's light. So, but when on the first one the light is dark. So we're gonna do t mod 2. And now on the first one it's dark. So we want the first one to be false. So we can just pass t mod 2 because that'll just pass into 0 there. I don't know if I feel good about this, but might as well submit since we got it. And it's clearly been a minute since we tried to submit, so let's try again. No, still too high. Let's see. Let's try. I'm gonna try a slightly different approach. I'm not sure this edge thing is going to work as well. Let's So what I'm gonna say is, if it's light outside, light, quote unquote, what if it's light outside? That means I'm gonna just store the dark pixels, and if it's dark outside, I'm gonna store the light pixels. So when I get into G, I'm gonna get my normal thing. I'm gonna go through, and on the first pass, because it's not light outside, we're gonna start with false. Then I can just say I will do exactly what I did before. So if it's in G and not light, so let's do this. If light, else, if it's in G, this is where we can go back to what we had before. So bin string plus equals 1 if it's in G, else 0, like that. If it's light outside, we're doing the opposite. Bin string plus equals, we're tracking the dark one. So this will be dark if R plus dr, C plus dc in G, else there. I think that looks good. So now we're gonna go through and we're gonna say, we're not gonna say if algo is that, we're gonna say if that's true and it's equal to, let's see, that's complicated. Let's do if light and the algo blah blah blah, we're gonna add it to G2. else, I guess then we'll do if not light, and algo int bin string comma 2 equals that. We will g2 dot add r comma c. So what are we doing here? We're doing our normal walkthrough here. We're walking through. But when we get to our point, if it's quote unquote light outside, which is, let's just do that if it's dark outside, which is our normal case from before, we're going to say, if we had a point, that means dark is default, so that means it's light. We're going to put 1 in our bin string. And then it's not light, so if that, now we're going to add all the dark points to the next round, because before it's kind of the opposite of what we were doing before. Now on this one, we're going to say if it is light outside, we're going to add a 0 if it's in the thing, because the in the thing is tracking dark points. And then else, glad I caught this one right here, we're going to replace it with 1. And then down here, we're going to say if it's light and the algorithm says it's on, then we're going to add it. Is that right? That might be backwards. Let's see. Because in grid 2, we're going to be, so if it's light, it means we're tracking, yeah, if light is default, that means in the grid 2, dark is default, so we're going to mark the ones that are on. If it's not light, that means dark is default. It means the next one, light's going to be default, so we're going to lodge the ones that are not light, that are dots, like that. And we're going to do G2. I don't think this is going to work on my example anymore, because all of this light and dark stuff only works in the case where my algo string starts with, has an on for 0. But it might work in this case, enough that I'm willing to try it. 2075. Return to day 20. It did work. Awesome. Okay, part 2. Yep, we're going to enhance it 50 times. This shouldn't, I don't know. I don't see why this is going to be, I mean, it might take a minute. Let's see if it's too slow. Enhance, if, let's see. Come up here, we'll do if t equals 2 before we enhance it the 3rd time. Like that. And then we'll change the range to 50. And we will yank, paste, and we'll make this part 2. And again, it might run for a minute, but I don't think it's going to be too, well, I hope it's not too long. Oh, too many prints. But no, that wasn't long at all. See if that works. Nice, okay. So that wasn't too bad. Let's go back here and talk about what we did, because I don't know if that's confusing. I don't know if this is confusing or not. So the algorithm right now only, actually, before we do this, well, I wonder if this would work. We could do something like, let's summarize first, and then so what are we doing? In the very beginning, we're splitting. We're in our algo string, single line 512. We could, if we want to be like extra careful here, we could put like an assert len algo equals 512. I bet that actually fails, because it's probably 513, because there's just extra new line on the end that I don't care about. So let's not worry about that for now. So we're splitting it in there. And now we're going to say, okay, so we're going to take all of the grid points and we're going to save the ones that are on. So by default, we're working in a default dark environment. So we're just saving all the ones that are on. Great. We got a print grid function. Nothing fancy about that. Although it probably doesn't work now in the new world. So now we're going to loop over our grid for range 50. you know, we're just, the two things we have to track are the length after 50 and the length after 2. Great. The confusing part is going to be, how do we handle the case where the background is flickering on and off? And so just in case it wasn't clear, I'm trying to think of the easiest way to show this. AC then, when you have some point in random space that looks like this, let's do just dot, 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 dot. That by default is going to lead to a bit string of 0, 0, 0, 0, 0, 0, 0, 0, 0, which in binary, or which in decimal is going to be 0. And so if our first piece of the string, algo, if our first one of these is 0, that means everything out in space is going to go from off to on the time flip. And luckily, well, or not luckily, I guess, but just it's going to happen when you similarly when you have 512, which would be, you know, when we have 1 2 3 1 2 3 1 2 3, that's going to become equals 511. So that's why this one's going to flip and back off. So after every round, all of space is going to be just flickering on and off, on and off, on and off. So to account for that, we can't just we could just expand our range out, right? And like loop over for this range, instead of doing -2, do -300 and +300, right? But the challenge is going to be then figuring out what's background noise that we're trying to, at the end when we're trying to count lights on, how do we count background noise versus, you know, plain old, you know, just the ones that actually matter. And we're still going to have weirdness on the edges. Like what we could do is we could, that's interesting. We could have a huge grid, flicker it, and at every step shrink our grid in a little bit, because the edges are also going to end up weird if you don't take them into account. So anyway, we didn't do that, so we're not going to go that route. We're going to go over our points, and for each point, we are going to find a binary string, collect the 9. And the trick here is to say, if we're light default, which is not the default, which was kind of our not default case. Maybe I should have called this dark to make it simpler. But in the default case, default is dark, and that means if the point is in G, is listed, then it is light because we're a dark default. Otherwise, it's dark, 0. In the light default, it's the opposite, right? If the point is in G, okay, so G lists we're light default, so all of the dark points. So then it's a 0, and else it's a 1. And then we just need to come down here and say, okay, so now we feed into our string and we get something back. Well, if that thing is equal to on and is light outside now, the next one's going to be dark default. So we want to record the light ones. If it's not light outside right now, if it's dark outside, or that means the next one is going to be light default. So we want to record only the ones that are dark. Hopefully that makes some sense. What I'd like to do is I think we could set this up so that it does solve. Okay, so anyway, so then we loop over all of them, enhance 50 times, print the length. I think we can set this up so that it solves both the flickering and not flickering case. And to do that, what we need to do is, so we could say something like if algo sub 0 equals this, and actually, you know what, let's just do flicker equals algo int algo equals that, and algo sub 1 equals, not sub 1, sub -1 equals dot. And so now we can say flicker times t mod 2. I think that. And so what we're basically going to do is, if that's not the case, if those two things are set, flicker becomes 1, and then now we're just doing 1 times t, so it's just going to be just like we thought before. For the case of like our example, there is no flicker. So this becomes a 0. And then we're just going to always pass false in here, which means it's going to be always dark default, which means we just always process it like dark. Ooh, I think that still fails, because now we still have this case where we're still going to save it dark default here. We're still assuming, this still assumes the next one is, so that's not going to work. So I guess I'll leave it for an exercise for the reader if you want to figure out how to write one thing that works on both cases, a flicker and a not flicker. But we're going to call it here for today. Thanks so much for sticking around to the end, and I'll talk to you next time.